And we're back here now with Chinmay, who's a technical evangelist at Epsagon. And Chinmay, you will take us a little bit about the capabilities of predicting failures before they happen by using observability. Can you tell us a little bit about that?
Yeah, sure. So as most of us know, the architecture has changed from monolithics to microservices. So I'm going to talk more about how observability has also changed from monoliths to microservices.
Sounds exciting. Okay, are you ready then?
Yeah, I'm ready.
Awesome. Then take it away, please.
Cool. So hello, everyone. Welcome to this session on predicting failures before they happen using observability. My name is Chinmay. I'm a technical evangelist here at Epsagon. A bit about myself. So I started off as a software engineer and then moved to a bunch of different roles at different companies, big and small. Fun fact about myself, I love traveling. And this is a picture from a place called Sapa in Vietnam. If you haven't been to Vietnam, I highly recommend it. It's a great place. So with that, let's get into our session. So in this session, I'll cover the 4 golden signals of SRE. We'll just brush over them. I think most of you might be familiar with it. We also see how microservices have risen over the past 10, 15 years. And then finally, we'll see how observability has changed due to the rise of microservices. So the 4 golden signals of SRE as defined by Google essentially are latency, traffic, errors, and saturation. Latency refers to essentially how long a process takes.
Good morning, Chinmay. How can I help?
Okay. Let's Google again. But latency refers to how long a process takes. The traffic essentially is the demand on a system. Errors are very self-explanatory. And saturation tells you how much of your resources have been consumed. So with that, we move on to how architectures have changed over the last decade or so. Earlier, we used to have a very monolithic kind of an architecture. So everything was in one piece of code. So there was this huge clunky application, which was really hard to manage and scale. And over the past decade, we have seen that application broken down into smaller mini apps, which are easier to scale as well as easier to manage. So we at Epsagon have seen our customers using microservices to a greater advantage. And the benefits of microservices are essentially developing features faster or even going to market faster. These benefits are not restricted to any industry or any company size as such. So as you can see, companies from different industries such as Adobe, Vonage, and different sizes such as Choco and Fabric have benefited from the use of microservices for their specific use cases. However, as Werner Vogels once said, everything fails all the time, and I completely agree with it. So what's the catch in microservices? The essential catch is that the architecture has become much more complicated, and that is why it is very difficult to troubleshoot and fix problems. Let's get into a more detail about this. So as most of you or some of you already use cloud APIs such as AWS or GCP or Azure, we also have a multi-cloud setup where a bunch of cloud APIs mix with each other. And then on top of that, we also have third-party APIs such as Stripe, Twilio, Auth0. So there is a huge chaos that has been created, and that adds to the complexity of troubleshooting or predicting behavior. Another important thing to consider here is the rise of containers, Kubernetes, and serverless functions. So these are essentially really easy to scale, and you can go from 100 containers to like 1,000 containers within a few seconds. So it's very hard to predict the behavior and the patterns, which makes it even harder to troubleshoot. And finally, we have seen a huge mindset change. In the monolithic application, the entire logic of the code was within the application, but now the logic has shifted in between microservices. So that's a huge mindset change, and we'll get into that later in our session. So this essentially has had a lot of business impacts too. As you can see, almost 3/4 of the issues are found by customers before the operations team. And every minute of downtime costs customers around $8,000 in revenue. That's a huge number. So how can we reduce those numbers? That's where observability in microservices comes into frame. Before we talk about observability microservices, let's just take a step back here and see what observability exactly means. Observability can be thought of as three pillars: metrics, logs, and traces. Metrics tell us what exactly is going on in our system. It may be at an application level or even at the infrastructure level. Logs tell us why something is happening, and traces tell us where exactly it is happening. Out of these, tracing is a newer concept, so I'll just dive a bit deeper into tracing. A trace essentially is a flow of requests through different microservices. So just because your architecture consists of hundreds or thousands of microservices doesn't mean a request will flow through each one of them. At most, it will travel through a fraction of those services. So because of the change in architecture over the last decade or so, traditional APM tools don't really work well in microservices. So why is that? It's essentially because, as I mentioned before, the mindset of the code has changed from within a service to in between microservices. So traditional observability solutions were focused on observing what is going on within an application and not between applications. They also focused on infrastructure monitoring. So, but these days, application monitoring has become much more important. And the alerts that were being sent out were essentially a bunch of alerts without any context. So I have seen SREs dealing with hundreds or thousands of alerts, and there is no context given there. So it's very hard to filter on which ones are important for you. And even if they're important, where to start troubleshooting them. There are also log aggregators out there, but logs really don't work as a starting point in troubleshooting. Tracing is a much more advanced and modern approach to troubleshooting, and then logs can help support that effort. And finally, there is also incomplete data. That is mostly because of the lack of payload visibility as well as sampling. So let's take a pause here and see what exactly are the things that are missing. So it's essentially the correlation between metrics, logs, and traces. This correlation is extremely important because it gives you a huge amount of data that you can analyze and predict behaviors from. And also the thing that is missing is contextual alerts, which helps you troubleshoot faster. So let's see how we can use modern observability in microservices to predict and troubleshoot behaviors. So at Epsagon, we believe that an observability solution should help you throughout your engineering lifecycle. On the right-hand side, you can see that an observability solution can help you predict your dependencies and thus help you during the design phase. It can also help you implement your features faster and also deliver them with confidence. On the left-hand side, you can see mostly troubleshooting, and that is during the testing phase as well as the production phase. So let's start with the 4 golden signals and how they look in microservices architecture. So the first one, latency. As you can see here, using a modern observability solution specific for microservices, you can see the breakdown of different applications by the latency that they have occurred. So in this way, you can see which ones are the best performing microservices and which ones are the lowest performing ones. And then you can essentially zero down upon which one you need to troubleshoot or fix. The same holds true for traffic as well. And by traffic, I mean at all layers. So be it the application layer, so you can see the throughput between applications or the throughput between endpoints, or be it at the infrastructure layer. So for example, here I've given an example of a pod. It can be containers, clusters, etc. Errors and exceptions are extremely important in any observability solution. So whenever you correlate metrics, logs, and traces, you can have a lot of filtering capabilities. So seeing a number of 400s is definitely important, but you should not be missing out any 500s. And a good observability solution should be able to help you do that. The same is true for exceptions. Some exceptions are more important than the others, and an observability solution should be able to bubble up those exceptions for you. And finally, with saturation, we know that infrastructure has changed over the last decade or so. Earlier, we used to have bare metal servers or on-premises servers. These days, companies have started to use more cloud infrastructure providers. So ECS, EKS have become much more prominent. So understanding how that infrastructure layer works and what's saturation in those infrastructure layers has become really critical. And as I mentioned before, an observability solution should be able to help you during your design phase too. So because the modern observability solutions are based out of tracing, you can actually see the entire architecture in a holistic view. This is something we call as service maps. So this basically helps you understand that whatever you have designed has been implemented properly. You can also see the latencies between different microservices. And in this way, you can actually predict failures before they happen. Using a distributed tracing-based solution also helps you bring focus to the problems, and that way you can focus on a specific group of microservices that are responsible for the problem. This way, you don't have to focus on the rest of the hundreds or thousands of microservices, and this will definitely help you reduce your troubleshooting efforts. And finally, as I mentioned before, payload information has also become really critical. So since the logic of the code has changed from within a microservice to between microservices, what is being transferred between microservices has become really critical. So if you have visibility into the payload information, that really helps you to understand what is going on in your microservices architecture, as well as troubleshoot faster. And with the correlation of metrics, logs, and traces, you have a huge data set available. So because of this huge data set, you can have filtering capabilities that are available to you, and you can actually add context to using those filtering capabilities. So that's why the alert fatigue essentially is reduced, and contextual alerts definitely help you during your troubleshooting time. So I'd like to summarize the session on what we have covered up till now. So we've seen the advantage of correlating metrics, logs, and traces. We've also seen how what are the four golden signals and how we can monitor them effectively in microservices. We also saw how to develop intuition about your applications and predict failures before they happen. And we also saw a bunch of things we can do to troubleshoot effectively. All this helps you reduce a bunch of costs related to your observability as well as your architecture. I'd like to end the session just by saying that a great observability solution helps you shift your mindset from being reactive to being proactive. So thank you for attending the session. If there are any questions, please feel free to ask them in the chat. This is my Twitter handle. Please feel free to reach out. And for exclusive giveaways, just visit epsilon.com/WTF-is-SRE. Thank you.
Thank you, Chinmay. That was great. And you're very on time. Again, I'm very impressed by that. So far, no questions have come in. But I would like to ask you, what in your opinion is the most important thing to consider when you want to predict upcoming failures or possible failures?
Yeah, so as I mentioned in my presentation, earlier observability was just being used for troubleshooting applications, but I feel these days the definition has kind of changed. So an observability solution should be able to help you throughout your product lifecycle. And so integrating an observability solution right from your development stage is important, and that essentially gives you more insights.
Thank you. That makes a lot of sense. There's a question that just came in. In the world of having hundreds of alerts sometimes, does Epsilon also correlate alerts? Good question.
Yeah, so correlation definitely happens at metrics and traces level. So Epsilon does give you the option of putting specific alerts on Epsilon traces, or if you are using Prometheus or Grafana, you can also put alerts on those. So there is an opportunity to correlate metrics and traces using Epsilon.
Fantastic. Thank you so much. So if we want to reach out to you, we can reach you on Twitter, right?
Yeah.
Could you also make your slides available?
Yeah. Where should I upload them?
On Twitter, if you can.
Okay, sounds great.
Fantastic. Thank you so much for your time.
Thank you.
And thanks.